morning, everyone. I'm Zing from SGInnovate. We are a government-owned organization that invests in and help build deep tech startups that leverage science and technology to make lives better for all. A big part of our work is to build a global community of leaders and doers who are driving deep tech innovations such as AI, medtech, quantum tech in our economy and society. Today, we are very happy to have a trio of Google developers, Hairizuan, Weiyuan, Akilesh, here today to share with us their knowledge and expertise. Just to set things, set the flow for today, right? We'll be starting off with Hairizuan introducing us with to the Google Cloud Run, followed by Weiyuan, who will be sharing secrets about KMS and Secret Manager in Google Cloud. And then Akilesh will end off the session by taking us through data exploration using BigQuery and Data Studio. Do leave your questions in the Q&A box below, and after all three presentations are done, they will be answering them. So without further ado, let's have Hairizuan up with his slides and take the stage. Hairizuan, please.
Hello. All right, you can all see my screen, right? Okay, so all right, so hello everyone. So I'm Hairizuan, currently working as a DevOps engineer at Acronis. With the rest of the speakers, I'm one of the co-organizers of this meetup group called GGG Cloud Singapore. So we generally tend to cover like plenty of the topics around the GCP platform, Google Cloud platform. So the one I'm going to introduce right now is one of the products on the platform, this product called Google Cloud Run, which was announced, if I'm not wrong, sometime last year. So let's jump straight into it. So what is Google Cloud Run? So this picture kind of sums up Cloud Run in the whole bunch of compute options that's available on Google Cloud Platform. So Google Cloud Run is another compute option that's available for people to use. So this picture kind of sums up on the level of abstraction that you will see when you are trying to use compute options on GCP. So if you are already familiar with like virtual machines, let's say on Amazon, there's this thing called EC2 or something that will be similar to your compute engine. And as you go from the bottom to the top, there are more layers of abstraction. So at the top, this cloud functions essentially is similar to your AWS Lambda. If you are familiar with the AWS stack, so essentially is some sort of serverless functions. So let's go from the bottom. So the bottom level is compute engine. Compute engine like gives you the most control, essentially just giving you a virtual machine. Then Kubernetes engine is putting a Kubernetes cluster on a bunch of compute engine. You have less control. More of the server stuff is abstracted away from you. And then the next layer is Cloud Run, the one in the middle. So essentially, Cloud Run essentially is a service where that deals with containers. Like it's not just like plain old, not serverless functions, but more like serverless containers. So let's say if you're familiar with all these Docker and everything, you can create containers out of your code, and then you can pass it off to Google Cloud Platform to run it on your behalf. So I'll be doing a demo like pretty shortly. So let me quickly go through. Okay, I'll skip this slide. Let me quickly go through a demo and what I will probably be doing with it. So this short demo essentially is trying to demonstrate how to deploy a simple application, a simple Golang application, which basically does nothing other than just saying hello world on the root URL. So it just replies hello world. And as I mentioned just now, this Google Cloud Run is a is a serverless product that that you pass it a container and then it runs for you. So with that, you kind of need a Docker file for that in order to build your container. So if you are familiar with Docker, and you can like technically toss anything into this Docker container, and then with that Docker container, you can just pass it on to Google Cloud Platform to run it for you. So with that, let's go to demo. Okay, right. I'll try to make this a bit bigger. So what I have here is a Visual Studio Code. Essentially, this should be kind of similar to what I was showing earlier. So this is the Golang code, and this is the Docker file. So it's pretty similar to what was shown on the slides. I'm just basically going to do the same thing as normal Docker command. So it's like the first step to get a container is you will want to build a container, right? So we will want to build the container and push it to a Docker registry. And in this case, in order to have it run on Google Cloud Run, Google does provide a Docker registry on a per project basis. So let's go up here. I'll be deploying on this Google Cloud project. So we need to get the project ID. Go back here. So in order to build a container that you can send over to this Docker registry on this Google Cloud project, what we will need to tag it with is gcr.io, and then project ID. And then after that, I can label it as anything I want. So the name of this application, I can just say it as Hello World V1. And then I'll build, okay, I forgot one argument. Okay, yep. So that command essentially builds a Docker container. So that builds it locally. I have Docker running on my computer. So with that, there's a pretty quick process where you just build a container. Then with that container being built, the next step would be to push this container to the Docker registry. So I kind of skip a few steps here because like I already kind of initialized my account on this computer. But if it is the first time for you, you first need to authorize your computer to be able to push to the registry. So it's not as if you can push to any registry, but yeah, you need to authenticate to it. So with that, the Docker image has been pushed to the Google Cloud project. So let's go here. So under this project, if you scroll down to view container registry, so the images will all be here. So this is what I just pushed just now. So the Hello World application, and then V1, the V1 tag. So like what I was showing here, is pushed to this project. Then application is Hello World, version is V1. So the next step to get this Google Cloud run thing so-called running, we'll just use a UI in this case. But typically, what people will use is other services like Google Cloud Build to like automate this whole process. But let's say if you were to do it in UI, like you want to experiment with it, how will you do it? So first, you just just create service. Then that way you need to select like where to run this container. So there has been an increasing number of regions and zones that Google Cloud Run is being made available to. So I mean, you can see some of the zones here. So in this case, maybe I'll just push a container to run in Taiwan. And then maybe I'll call this service Hello World. So by default, Google Run applications are deployed such that the endpoints that is revealed to the world is, I mean, essentially it's not public by default. So if you deploy your application first time, it's private by default. So if you want to make it a public service, you need to check on allow unauthenticated invocations. So I think there's also a description here. Check this if you are trying to create a public API or website. So to make things simple, you don't need to go through all that authentication stuff. I will click on this, then just click next. And then this part is where we will refer to what we did just now. So the container that we push. So once you click on it, you can click on Hello World, click on V1, then you can click on Continue. So with that, we selected our image that we are going to run. You can, if you click on Show Advanced Settings, there are other stuff that you can actually configure it with. So like which port do you want to, you have exposed your service to. So in an earlier Golang application, we expose it via port 8080. And on Docker file, we also expose 8080. So in this case, we'll just stick to 8080. Then another thing that might be good to look at would be this thing about capacity. So in this case, for Golang application, running it with 256 megabytes of memory is fine, because essentially Golang application tends to be quite small in terms of memory footprint. You don't need a lot of CPUs to be allocated to it. So if you try to click on the amount of CPU, now you can go up to 2 CPU. But yeah, I mean, for this Hello World application, you don't need so much resources to run it. What would be interesting to look at is this thing called maximum request per container. So this one is the measure of concurrent requests that your application can handle. So something like Golang is fine. It can take in, it can handle like multiple concurrent requests at the same time, like requests that come in at that very moment, like within that 1 second, like 5 requests, it can handle all 5 at the same time. But maybe some, if you use something, if you try to create an API using like a language like R or something, R is a single-threaded application. If you just use R as it is and try to create an API, so for those users who are familiar with R, there's this library called Plumber that allows you to create API endpoints. But because R is a single-threaded, so if you try to throw two requests at it at the same time, the other request will be like hanged, like temporarily suspended while it's processing one of them. So R essentially, if you are using R for this case, ideally you want to set it as 1 here, so that if like 2 requests come in at the same time, Google Cloud Run will spin up another container and allow the other container to take in the other requests. But in our case here, for this Golang application, we can set it to 80 because like you can easily handle that. So with that, you can just click create, and then we'll just wait for this Google Cloud Run to create the service. So, okay, so I mean, I wanted to explain more, but okay. So this whole thing has been deployed. So they provide a URL endpoint that you can access to. So if you copy this URL and then you go to it, you can view that it's working here. So hello world. Okay. Where is my cross button? Hold on. Okay. I need to cross this. Okay. So a bit of explanation for this. This whole Google Cloud Run project is all based on this other open source project called Knative. So if you are ever curious, like how this whole thing works, there is this. If you click on the YAML tab, then you will see this whole YAML file, and then you see at the top here there's this thing called serving.knative.dev /v1. So this whole project is all Knative, and then like you can actually configure, you can actually alter the values here if you know what you're doing, and you can then deploy a new version of it. But yeah, I mean, if you want something, if you want to use it as simply, you can just like go through the UI and just click through this way. Another new interesting feature that Google Cloud Run provides quite recently is this thing about managing gradual rollout of your applications. So let me go back to the code base. Let's say if I change the Golang application, maybe I add a V2 here. Yeah, so I add the V2. So essentially now, and I add V2 in front here to make it like obvious. So so let's say if I have this new version of this application, and then it has V2 in that will return. So let's build this as a V2, and this will be the new version of the application that I want to deploy. But let's say if I'm the developer here, and then I'm not super confident that it will work out well, and like I want to reduce the impact of this application on production workload. So how can I do this? So let's push this container. Okay, let's push the container. Container is pushed. Go back here. So let's say we have that V2. We want to deploy this V2. We can click on edit and deploy new version. Is it pushed yet? Okay, pushed. Okay. Then we can select which is our new container that we want to push into this new version. We click on V2. We can continue. Let's say we don't want to make any changes here. This is the important one. Serve this revision immediately, the option at the bottom. So previously, because the application has not been deployed before, so 100%, naturally 100% of the application will go to your V1 of your application. But in this case, let's say if you have this new version of this application, and we aren't too sure whether it's good enough for production workload. So maybe we want to do a 50-50, like 50% of our workload goes to the old one and 50% goes to the new one. So first we will like uncheck this, serve this revision immediately. We will uncheck that. So that means this thing will be deployed, but it will not serve any traffic at all. So we'll deploy this. So that's deployed. Let's give it a moment. Okay, so it's deployed, but it's not serving any traffic. So let's say if we copy this, copy the endpoint here, it's still showing hello world. So you go back to the Cloud Run interface. So let's say if you want to do a 50-50 traffic split, so how will we do this? So if you click here, you click on manage traffic. Then I can set it to 50-50. So 50% of my workload will be going to the old version, and 50% will be new version. So I click save this. So let it like reconfigure. So now if you see 50% of the workload goes to the old one, 50% goes to the new one. So if you go to the page to view, if I click on clicking refresh, eventually you see a V2. So sometimes it will show a V2, sometimes it will show a V1. So let's say now that's the thing, like now we have some sort of way to like gradually roll out our workload as time goes by. So if you are more confident, then eventually we can go back to the console, and then we can like set it to 100 to the new version or something. But yeah, so these are one of the newer features that was introduced. So let's go back to the slides. So just one more additional thing that I will cover. So how this Google Cloud Run is priced essentially is priced on is priced like you will be charged once the container is invoked. But let's say in the case where let's take the most simplest case where you have only one concurrent request at any one time. So the moment your container is started, then the billing begins for that. The billing begins, and then the moment the function ends, your container dies, then it is then the billing stops there. So it's from request start to request end. But in the case where you have an application that is able to handle multiple concurrent requests, so as you see this image here, let's pretend that you have a container with its start and end, right? So the only billable time it is from from the first request start time to your last request, the processing end time. If you want to find out, so there's a few trade-off when you set your concurrency and everything, like, in order to handle more concurrent traffic, you sometimes need more memory. So there's some sort of trade-off where you need to select here. So if you have if you're kind of wondering about that point, there's a YouTube link in this slide that kind of like talks about specifically about these set points. So this one, it kind of dives deep into the internals of Google Cloud Run itself and how it's built. So there are other interesting things that you can do with Cloud Run. So the case that I shared here is essentially a synchronous HTTP workload. But in the case where you need to use, you need to do asynchronous workload, like, you need to send messages via a publish subscriber product. So Google Cloud has this thing called Google Cloud PubSub. And if you combine that with Google Cloud Run, you can do asynchronous workload with that. So essentially, you have a service that that's kind of cheap to use, and then you can you only be charged only when you trigger it, when you send message to PubSub. Just now I showed you another interesting thing about the gradual rollout. And recently, Google Cloud Run has just introduced VPC support. So previously, let's say if you have some internal API where you only do your application API endpoint can only be in is under VPC lock, right? So now there's VPC support. So that's that, and there's now higher resource limits. So now there's 2 CPUs available per for Cloud Run. Hopefully there'll be more in the future, but now you can do more interesting things like stuffing a browser into a container, or maybe doing inference machine learning tasks. So with that, kind of come to the end of my sharing. So I'll just stop share here.
Yeah, thank you, Hairizuan, for your wonderful sharing. Next up, we have Weiyuan, who will be sharing his slides. Weiyuan, are you there? It seems like he may have some trouble with his presentation currently, some technical difficulties. Akilesh, are you ready to go for now first?
Yeah. Sorry, yeah.
Yeah, so sorry about that. Yeah. Thank you, Akilesh. Yes.
Hi, my name is Akilesh, and I've been working with Google Cloud for about 3 years now. And I've been using BigQuery extensively for data analysis and a bit of modeling, but not that much, mostly for data analysis and data processing. So I won't take much of your time. Let's just dive into what I wanted to share today. So I hope everyone can see my screen. Let's have some difficulty. Sorry. Okay. So that will be the topic for today. We will be discussing a little bit about BigQuery and Data Studio, and we will be trying to analyze the current situation, the COVID data situation with BigQuery and Data Studio. Who the agenda for today is, so yeah, a little bit of introduction into BigQuery and into Data Studio, and we'll try to do a demo with creating a report using BigQuery and Data Studio. Who is this for? So this is not a very deep dive into BigQuery or Data Studio. This is more for anybody who is interested to start with something. So if you start with data analysis, most of the time, most of the articles out there say that you will have to start learning a new language, let's say Python, and you have to learn new library in Python, pandas for data manipulation. before you can start drawing those, putting up a dashboard and having those really nice graphs for present to somebody. So this is mostly for those who are interested in data analysis and some SQL. This is also for somebody who's interested in data analysis and you have no coding knowledge at all. You just have experience with Excel. And you've heard of BigQuery, which is one of the most powerful products that Google has introduced for data analysis and data processing. And you want to know a little bit more about BigQuery. So that's kind of the target audience. So what you will need a GCP account. How to create a GCP account and to register for it, you can just do a simple Google search, and all you need is a Gmail ID, and you can register for a GCP account. You will have to provide your credit card. That's what I did. But the catch there is you have $300 free, which Google will provide for you for a year, which you can use for your simple tasks. And for if you're just doing some basic data analysis and you would just want to come up with a nice report, I don't think you will eat up those $300 anytime soon. So, and then you will have to set up BigQuery, which is again very straightforward. So we will be forwarding this slide deck. And if you follow through with this information in this link, you can find out more information about how to set up BigQuery, how to enable the APIs in the Google Cloud Platform, which is slightly beyond the scope of this talk. And you will have to set up like Data Studio. So Data Studio, all you have to just do is go to datastudio.google.com and log in with your Gmail ID. So that's that. So a little bit of introduction on BigQuery. So what BigQuery is, let me just search for BigQuery. So as it says, it's a cloud data warehouse platform. It's used for data analysis and data processing. It's super fast. And let me just go back to that slide. So it's serverless. It's highly available and highly scalable. And you can run SQL-like queries with BigQuery. And as the name suggests, it's BigQuery. And it's like a serverless enterprise level data warehousing system. So how fast BigQuery is, there is a small video on that. There's like plenty of videos actually on YouTube on how fast BigQuery is. So if you can query like terabytes of data in seconds or maximum minutes. So that's how fast BigQuery is. It comes at a cost. Like there are a few things that you have to be very careful around BigQuery. One of the things is if you use a select star statement, let's say if you're familiar with SQL, and if you use a select star, it's going to scan the entire table. So you get billed for the entire table, scanning the entire table. So we'll try to discuss a little bit about cost, but our main focus will be on to how to build the dashboard here. So if you want to know more about BigQuery, again, these are what we call quick lab sessions. So there are quick labs for BigQuery for data analyst and BigQuery for data analysis itself, and BigQuery for machine learning. So BigQuery recently in 2018, I think, introduced machine learning in its portfolio. So you can do, you were able to do linear and logistic regression. Now you can do more clustering and recommendations as well. So you have these quick labs and it's more self-explanatory. Just have to go to these links and then follow up and enroll for this session. And you can just follow through and know how to like learn more about BigQuery. So what is Data Studio? Data Studio is just a little bit of introduction on Data Studio before we start building a dashboard on our own. It's a business intelligence tool developed by Google. It's free again, it's fully managed, and you can have multiple data sources. It supports multiple data sources. So just I'm going to switch to the next slide. These are the data sources that you can connect with Data Studio. So right off the top is BigQuery. You can connect to Cloud Spanner. It's a product offered by Google. If you're in the marketing space, you can connect to Campaign Manager. If you're in the marketing space, with Google Analytics, you would have known about Data Studio a bit. You can also, if you have all your data in an SQL server, you can connect to the SQL server. So these, you can connect to SQL, MySQL, your own SQL server, or like Cloud SQL offered by Google itself. And you can also upload a file and you can start analyzing your files. But there are some limits to when it comes to file upload. You can only upload, you can only have 1,000 data sets per user. And the total storage is only 2 gigabytes, and you can only upload 100 uploads per day. And the file size per data set can only be 100 megabytes. So if you have a file size that's less than 100 megabytes, you can easily upload that to Data Studio directly and start visualizing, instead of like uploading data to BigQuery and then connecting that to Data Studio. So one of the important reasons that you want to connect to BigQuery and then analyze your data is for the speed and performance. So let's try creating a report. So first off, I go to datastudio.google.com. So that is all you have to do. Once you're signed in, you will see this page. And let's say you're creating a blank report. All right. So your data set, the first thing you have to do is connect to your data set. So you're choosing BigQuery as your data set. I'm using BigQuery now also because like BigQuery offers a lot of public data sets. So this is the project that I've been using with the Google Cloud platform. So in public data sets, I choose my project. And then under this public data set, I'm choosing, just going to type COVID, and there is going to choose the first data set that I see. So it's for COVID-19, the geographic distribution worldwide. And I add this data set. So it says, do you want to add this data to this report? You just say, add this to the report. And first, let's just say we're going to name this my COVID report, or any name that you're comfortable with. Sure. Oh, okay, minimize this. So here, there are just two main things that you have to know about Data Studio. So one is called the dimension, and the other one is called the metric. The dimension is anything that is dimensions are what you're measuring, and metrics are what the measurements are. So what that means is, let's say so here we're having the countries and territories and the record count. So the record count is a metric because it's quantifiable, and the dimension is the measurements that you are actually quantifying. So let's say you want to know first how many countries are being affected by the COVID situation. So let's say I want to draw a bar chart and say what is the number of confirmed cases by country. So you can move the date here for now. So we're not interested in the date right now. So let's just go to the dimension. The dimension is countries and territories. And I'm just going to say, this is my metric. Right? I add the metric here. I'm only interested in the daily confirmed cases. And here it automatically recognizes that it's a integer field, and it does a summation. You can also do an average. You can do a count. You can do a count distinct, etc. So there are multiple options available here. So for now, I'm just going to do the sum. And you see that the number of confirmed cases by country, like United States, is the highest for now. So if you want to change the style of this, if you want to change the type of chart, you want a horizontal bar chart, that's as simple as that. Now, this is in descending order. So if you want to have this in ascending order, you have to do is scroll all the way down. So here it says, this is by the number of confirmed cases daily. So just switch that to ascending order. So it's going to say Lesotho is having the least number of cases so far. So for now, I'm just going to switch it back to descending. And let's say you want to know the total number of countries that have been affected. So they have this tile called the, there is a tile. So here, if you say this is a summation of the daily confirmed cases. Again, I'm going to remove the date here. Just going to put my country here, and the default is count distinct. So it's saying that 210 countries that have been affected by this entire COVID situation. So let's say you want to know how many, you want a date range. You want to say how many cases were there in the month of March. Or let's say first, before that, let's just draw a time series and then say how many cases by date. So let me just align this, or like make it slightly bigger so that's clear. So they have a date here. So you just take your date and you add it in the date dimension, which is already done for you. And in the dimension, you can, so you want your daily confirmed cases. You don't want the record count. The record count is the number of records that's in the data set. So you don't want that. You want the number of counts in the, you want a daily confirmed cases. You also want to see what are the daily deaths. So you just add another metric here. So that's going to give you two lines. So this is the first line here is the number of confirmed cases, and the second line here is the number of deaths, like overall. Now you just want to know how you want to like filter this by country. So you just choose a filter. This is called the filter control, and you simply add the filter here. And in the filter, so default is countries and territories. So so the way to visualize a Data Studio report is you click on view and you choose country. I'm just going to say, click on this and Singapore. So you see that there was an increase in the number of cases. What's the daily trend, etc., etc. Right. This data may not be as accurate as what SD gov.sg provides, but that's how you like filter using just the country. And if you want a date filter, they have this nice little date range widget as well. So you put that there, and the date range gives you a wide variety of options here. So it's automatic date range. So especially when you're in e-commerce, you want to know like what was your count the last 7 days or last 14 days, or what was the count today, like new people who visited your website today or yesterday. So they have like a variety of options that you can choose from. Let's just say for the sake of this presentation, I'm just going to with this quarter, or let's say this year. So that is just going to show me data from Jan through December. So this is the trend this year. So if you choose last year, then that's the trend last year. So you're just going to have a small dot in December. So because there was the entire situation started in the end of last year. So that's how you apply a date function. One of the things that you will have to note with Data Studio is the headers. So you see that there is no headers out here. I'm not having a header here. That's one of the things that's been asked in the support forum as well, to have like a header that's built in with the charts. But for now, you will have to like choose a text, and you will have to add a header here and say distribution of confirmed cases versus deaths. So the other important thing here is you will have to choose this chart along with the header, and it's like it's not a compulsory thing, but it's better to do this. You group these two together. I'm sorry. Yeah, so you group this together, and that means when you move this around, your header also like travels with you. Otherwise, it's going to be hanging somewhere. So that is kind of like a basic introduction into like how to use Data Studio. You have a wide variety of charts. You have like geo charts, Google Maps that you can play around with. All you need is like coordinates of like countries. I can try using a geo chart. So now if you look at view, it's only going to show you the page that was like visible. So we moved the chart slightly down. So your chart is like stuck halfway. So the way to like fix this problem is you go to page and current page settings, you go to style, and you just increase the size to like 1200 pixels. Just make sure that it's like it fits all the graphs and charts that you're interested in. And there is the other, so to add a header title as well. So you choose a chart and you go to style and you scroll all the way down, and then you say, suppose you don't want the legend, you just say none here. I want the legend, it's better to have the legend. Okay? And you can choose where you want to place the legend. And here you can say, if you want the chart title always, you can always say, sorry, this is slightly slow. Let me try with this chart. Not sure why that's not enabled. Right. I'll get back. So it's basically saying the chart header. So there will be three options: always show, show on hover, and do not show. So if you say always show, then it's going to like show up the chart title for you. Like there'll be a little space that's created just above the chart where you can add your chart title. You'll have to like create a text and then put up your chart title there. The add border shadow is a nice feature. So this is like adding a border shadow around the graph so that when you click on view, you have a really nice way of like presenting to your audience. You can also like add a background. You can put up an image and you can add either by URL or you can upload from your computer, and you can have a nice background at the back. If you want to add more data, you just click on add data. Choose like before, choose your data set and like it will add that data set as your new data source. But the thing about the thing about Data Studio here is you cannot join two data sets. Like you cannot create a chart by joining two data sets, data sources within Data Studio. So for that, you will have to use like, you'll have to have like BigQuery, like, and then create a view, and then like expose that view to Data Studio as a new data source, and then query that data source. So that is kind of like an introduction into Data Studio itself. And I was playing around with, so the other one, sorry, I forgot to mention was calculated fields. So let's say you want to create a new field. Let's say they already, this data set already gives you a year, day, and month. But let's say you didn't have these three fields, so you want to create a new field. All you have to do is you add a new field that's right at the bottom, and you say, let's just, for the sake of this demo, let's say my calculated field. And here you just say year is a function that's available with Data Studio, and you say which field you want to use as the year. Okay, it's slightly slow if I'm not wrong. So when you see this green tick mark, it means that your function is correct. There are no errors with your function. So you save that and you click on done. And you have this new field that's been added. So that's your new calculated field. So let's just try and add a bar chart. So we're trying to calculate a year-wise distribution. Can I move this slightly up to make space for my new chart? I'm not sure why. Maybe it's the presentation that's making it so slow. So here, instead of, I'm gonna remove the date, and in dimension, I'm gonna add my new calculated field. So it says in 2020, there were like number of cases more than 2019. So that's how you add, you create a new calculated field. For complex operations, like if you want to have a row number, or you're playing around with ranks, you can use BigQuery itself to create that. So in BigQuery, you have the BigQuery public data, and you can search for the public data here as well. And you see that this is the data set that we are actually using. And if you the schema of the data set is available here, and the details of the data set is it's got like 19,000 rows, 19,666 rows, and this is the table size. And you have a nice little preview of the data set before you want to play around with it. So any calculated field that you create does not appear here. That only appears in like Data Studio. So before I started, there was this mention of the 1,000 data sets per user, etc. Right? So I'll just quickly explain what a data set is in BigQuery. So in BigQuery, this is the project, and in which you'll be creating your data sets. So this is called a data set, and a data set is like a collection of tables. So that's pretty much the simple explanation to that. So if you look at the Google Mobility Report, or let's say Chicago Crime Report. So Chicago Crime is the data set, and crime itself is the table. So that's a little bit about BigQuery here. So one of the things is whenever you run a BigQuery query, so let's say you're in the crime report, since that's readily available, when I do a select star here, it's going to say how much, it's going to show you how much data will be processed by this query. So this is what I mean by the cost. So when you do a select star, that's where that's the total amount of data that's being scanned. But if you just choose, like, say, unique key, so it reduced from 1.4 gigabytes to 53.4 megabytes. So that's where your cost kicks in. And the cost is like for 1 terabyte. When you start using BigQuery, the first month, I think 1 terabyte of data is free. And then after that, for every 1 terabyte of data that is being scanned, you will be charged $5. So that is the cost breakdown. So you will have to be very careful about like certain statements like select star. It's better, like one of the best practices while using BigQuery is never to use the select star statement. So that's a bit about BigQuery. And how you can view your cost is very simple. You go to the Google, you click on the Google Cloud Platform. And here under billing, you click on view detailed charges. And here you will see products. So these are your projects. I've got 3 projects for multiple purposes. So under products, you can just choose BigQuery. So this will show you the project cost for, sorry, the cost that BigQuery has incurred for all the projects. Right now, I don't have any costs because the queries that I'm running are really, really slow. So sorry, very low in the amount of data that's being used. So this is how you can keep track of your cost. You can also set up limits on how much cost BigQuery should take under budgets and alerts, if I'm not wrong, but that's like beyond the scope of, set a max budget of $1. So I've still not reached that. And I've set up alerts for like 50, 90% and 100 as well. So that's pretty much it. That's like an introduction into BigQuery and Data Studio and how you can start your data analysis journey without having to learn like a new language or build some interesting dashboards. So yeah, that will be the end of my presentation.
Thank you, Akilesh, for the amazing demonstration and the in-depth presentation. Now, let's just have our last panelist up. Weiyuan, feel free to showcase your presentation.
Thanks, Ziying. Okay, so let me share my screen now. Okay, so I've presented my slides here. So first off, apologies about the technical difficulties earlier on for those in the audience. So yeah, my name is Weiyuan, and today I'm going to be speaking about secrets and putting these secrets or embedding these secrets into your serverless tools in GCP. Okay, let's get started. Okay, so yeah, short introduction. My name is Weiyuan. I'm a technical lead in Rakuten Viki. I'm also concurrently a Google developer expert on cloud technologies, and I'm volunteering together with my other two colleagues who have spoke before me. We are volunteers as organizers of GDG Cloud Singapore. So if you're interested in GCP related events or meetups, we do this webinars, once in a few weeks, or in the future we also have our physical events as well. Okay, so let's get started on our topic today. Before going to the nitty-gritty details on how to get these secrets into your serverless applications, I want to talk about the concepts to be covered in today's topic. So we have two important words over here: secrets and serverless. Okay, so just go on the simple term first for secrets. I think for application developers out there, you know that this is very much synonymous to the word credentials. So if you are running an application where you need some data store, of course, these credentials could be username, password for those data stores itself, because you want to make sure that sensitive information in the data store is not publicly available to other people. Okay, so you need to have some secure access. Or if you're using some third-party libraries, you need to get some API keys, and because this API key is tied to the quotas, perhaps you have purchased like a certain plan, for a certain quota, and you don't want to have this API key leaked so that other people will be reaching on the quota. So again, this is considered as a secret as well. Okay, and if your application itself has some dependencies on some private code base, packages that you install, of course you might want to embed things like SSH key, because this has access to your repositories. Again, this is another thing that can be classified as a secret. And the list goes on and on. Okay, but what exactly is not a secret? So if you go on the other side of the fence, if you build web applications, things like JavaScript assets and CSS, those are to be loaded on the browsers. So I wouldn't consider those as secrets. Okay, and then things like translations, again, people have to read them on the site. Publicly available, not secret. Okay, and this last part, I would say, is kind of like a gray area, like configuration for your application. Maybe for things like hosting, if you need to call a single API endpoint, you don't want to hard code it. So it's kind of like configuration where you inject it as environment variables into your application. So it's actually this, it's not exactly a secret, but you can, I mentioned it's in a gray area because you kind of can use these tools that we'll discuss later on, in managing your secrets, to manage these configuration variables as well. So to inject them into your application as you deploy it. Okay, so that's about secrets. Next thing we want to look at is serverless. So what are the serverless tools in Google Cloud Platform? Okay, but before going into that, just to briefly mention, what exactly is serverless? And one of the words that I like to describe serverless a lot is the word manage. But manage itself is still a bit ambiguous. What exactly is the part that's managed by the provider, when you're using these tools? Okay, just to look at a very brief definition, essentially you have this mumbo jumbo here, but essentially the words that we need to focus on is the cloud provider runs the server, and they manage the dynamic allocation of resources. So what this means is that physical server racks, these are done by the provider. Provisioning of VMs, those are managed by the provider. You don't even need to worry about managing your VMs. Scaling up and down, load balancing, these are all taken care of by the provider itself, when you're using serverless tools. And as the company, all you need, or as a certain party using this serverless tool, all you need to worry about is the product, the application code that you ship along with this serverless tools. Okay, so looking at the array of all the products today, I think Hairizuan mentioned about this earlier on. So I'll just be a bit more brief on this. There are 5 different tools that you can use to develop applications in GCP. So you have Compute Engine, which is essentially VMs, Kubernetes Engine, which is the orchestration system, Cloud Run, running applications with Docker images, App Engine, a mix between Docker images to, if you just want to ship your application code, for example, if I have a node service, I can just ship my code. It will just work as it is. And then Cloud Functions, which is a singular entry point to a single function that you have deployed for running this, a single path for that application. Okay, so looking at this, very immediately we can see that the later 3 choices are our serverless solution. So Cloud Run, App Engine, and Cloud Functions. Okay, but for today's presentation or discussion, I'll be focusing more on Cloud Run and App Engine instead. But for those who have not used GCP before, don't worry too much about the semantics behind all these different tools. In fact, I will even take a few steps backwards and say, all you need is a working background on Docker images. Because essentially in Cloud Run, all you need is a Docker image, as mentioned by Hairizuan earlier on. App Engine, there is a configuration called App Engine Flex Custom Runtime, which you can use a Docker image to deploy your application onto as well. Okay, so we'll be using this similar configuration for Docker images on our serverless tools. Okay, and for today's discussion, it wasn't something that I just simply explored. I wanted to, in fact, I had a problem that I wanted to solve beforehand. So I mentioned earlier on that I was volunteering for GDG Cloud Singapore. I'm still currently volunteering for it. And for some of our meetups that we organize, sometimes at the end of the event itself, we usually, sometimes we want to do this lucky draw. Let's say if we have a photograph booked by one of the speakers, we want to give it out. We want to do it in a fair way. So, you get people's information via some Google Forms, and then you put it through this, let's say some lucky draw application, and then basically, you just pick out a lucky winner from there, okay? So, in our current situation, okay, so basically, it goes something like this. You just choose one single name, and then basically, you have one winner from there, okay? But the thing is this, so before, when we did this before, we had to use free applications, other websites that serve this functionality. But if you have used free websites before, you know that there's usually things like ads, usually things like pop-ups that can appear, and that's not something that you want to show during your events, and especially if you're recording it. So because of our knowledge of Google Cloud, between me and one of my colleagues, we were discussing, why not let's try and get a free application like what you have seen over here and deploy it to one of the serverless applications, okay? But that's not just the end of the problems. The other problem is, as I mentioned earlier on, we gather the credentials from the Google Forms. So this information is streamed to Google Sheets. So as a developer, I also want to make this entire process automated. How do I stream this information directly from Google Sheets over to my serverless application? The thing is this, you can make that sheet publicly available such that any of your applications can just call the Drive API and get the information. But this is not the best thing to do because some of this are private information. We don't want to expose the private information of our users. Okay, so to solve this, instead of publicly exposing the sheet, what we can do is keep it as private, but use this entity called service accounts. So service accounts in Google Cloud Platform is kind of like user accounts, but it's a system, it's an account that you can use within your workflows or systems to represent a single entity. And you can assign roles and privileges to this entity to signify that you can do this, you can do that. So in this case, I can assign the permission to be able to read Google Sheets from this service account and then embed this service account within my serverless application. But you can't just tell the serverless application, be this service account. You still need to have some secrets. They need to take these secrets and then run it and say that, to be able to prove that they are this service account, okay? So this is where the problem comes in. How do I put secrets into my serverless applications? Okay, so there are two ways that we can do it. Okay, the first way, I'll say this is kind of like the raw way that most of us have probably done before, be it on serverless or on non-serverless tools, where what you're looking at, so essentially this is not a tool, but this is more of a methodology. And what you're looking at is essentially just putting a secret into your Docker images and then deploying that Docker image. Okay, so the example here is essentially how to do this. Essentially, let's say if you're building a local environment, you put your, let's say your env file there, and then you build your Docker image and you push that Docker image up. Okay, deploy that, so that's part of the application. Once that image is deployed, as the container itself, they will have access to that secrets file. Okay, so it's a very simple process. Again, it's more like a method, it's not a tool. Okay, so some advantages regarding this methodology, there's no additional cost. If you're already using Docker images, you already have a image repository, like Hairizuan mentioned earlier on, image repository within GCP. So you're already paying for that. Okay, so there's no additional cost to using this. And it's somewhat easy to understand because the file is already exposed within your system. You can just amend it very quickly. Okay, and when you deploy, it's the same thing. It's the same file that you see in the local system as the production or staging environments. Okay, but there are a lot of disadvantages to this approach. I think some of you would have already disagreed with this approach from the start. I think it's not a management system, essentially. If I build it in my local environment, I have a copy of these secrets. I need to have my colleague who needs to make a change or update some secrets and delete some secrets. essentially we need to coordinate, let's say face to face and say that, okay, I have to delete this from my file, you have to delete this from your file, I have to add this to your file, do the same to your file as well. So it's not a very manageable way of managing your secrets, okay? And the issue is this: you should never look towards embedding your secrets in a Docker image, especially in long term. Like if you're just starting a project, I can understand, yeah, if you need to do this very quickly just to get an application running. But in the long run, if you embed your secrets in the Docker images, what you're doing is you're increasing a surface area of being attacked, or rather exposing your secrets. Because the issue here is that the secrets in these Docker images, let's say for a certain user who is allowed to deploy this application, but they are not supposed to have access to some of these secrets, essentially what they can do is just pull this Docker image, run it, they can see all the secrets inside. So essentially your job becomes more complex. As a DevOps personnel, you need to now increase, like you need to set the access control policies, not just for accessing the secrets, but also for accessing the Docker images. Okay, and one of the big issues is this: if you couple secrets into your images, controlling of your code, doing things like rollback becomes very hard. Let's say if you have a certain build of your code with embedded secrets, and then okay, you deploy it, and then let's say you make a change to your code, okay, you deploy for a second time, and then for a third time, you make a change to a secret, deploy for a third time, and you realize somewhere along the line that you need to roll back your change on the second deployment. But you can't just roll back to the first one, the first build, because your secret has been changed on the third build. So there's some, because let's say it's outdated secrets. So instead of rolling back to the first one where, let's say the rollback process is very quick, you instead now have to build a fourth build, which is the old code with a new secret. So, in fact, this means that, let's say if you need to do very quick rollback in emergency situations, you need to instead do a roll forward, which may take more time to fix the problems instead. Okay, so let's try to look at improving this method. If you want to bake secrets into our images, is there a way to secure the access of it, such that people who have access to the Docker images, they can't view these secrets? Okay, so you can use this tool called the Key Management Service to do that. And what KMS essentially is that it's a service for managing encryption keys, as well as for permissions to encrypt as well as to decrypt files. Okay, so what you can do is you can authorize users or service accounts to be able to encrypt or decrypt. So usage example for it. So the first thing you can do, or the first thing you should do, is to set the access control first. So you need to grant permissions to the different user accounts or service accounts. Are they considered the encryptors? Are they the decryptors? Or can they do both at a certain time? Okay. And after you authorize the permissions, so the permissions is supposed to be linked to your workflow. So let's say as a certain user who have access to these secrets, I should be both the encryptor and decryptor, so that I can decrypt the secrets, make changes, encrypt it again, and push it as part of my build. And then as for the service account, as part of the serverless application, they need to be able to decrypt this file so that they can run it with the application code. So you can see over here, the encryption and decryption essentially is just using the G-Cloud client, G-Cloud KMS decrypt, and then you just put in the file's details. For encryption, it's the same, just put in, instead of decrypt, is encrypt. Okay. So what are the benefits of using KMS in conjunction with baking, as compared to the earlier first method? Where, okay, so now you can see that immediately there's one benefit, which is that the file itself is encrypted. Hence, if I have access to a Docker image, I cannot look at the contents unless if I have the permission to decrypt it. So this means that we don't need to extend the access control over to our image repository. Okay, but it's still not a scalable method. Now imagine if I have to make updates to the secrets, I still face the same problem. I still need to coordinate with my colleagues into updating it, at the same time before let's say if I need to decrypt, I need to update, and then I need to tell my colleagues, please decrypt it and update it on your side as well. Okay, and your build is still coupled with certain secret versions, so it's still kind of a problem there. You can't do rollback, you have to do roll forwards. Okay, so that's the part on KMS. I think we sort of identified that it's not exactly the best methods. But those were methods that we could use before. But more recently, there was this tool that was released, and it's called Secret Manager. And this is a very useful tool. So I'm going to show you what you can do with this in terms of managing secrets. Okay, so just a brief introduction on Secret Manager. Essentially, it's a managed solution for you to store your secrets as well as the secret files or files with secrets. Okay, and it's kind of it's a better tool as compared to our previous other tools because it comes with versioning. So now you can maintain multiple versions of these secrets. Okay, so how do you use Secret Manager? So there are multiple ways of using Secret Manager. One of the ways is to start from the console. So console meaning the website for Google Cloud Platform. So from the console, you can just create the secret directly, as you see over here. You just need to put in the identifier, and the value is corresponding to that secret. Okay, and then you just click create, you'll immediately be created. Okay, the next thing you need to do, similar to KMS, which is you need to authorize who is able to read and write these secrets. Okay, so you can do this via the IAM on the console for Google Cloud, or you can use the G-Cloud client. So you can just put in the permissions here. In this case, I've set it such that a certain service account can read these secrets. Okay, and so finally, last part, after you given the read permissions and write permissions to the user accounts and service accounts, what you want to do is to now solve the problem. How do I retrieve these secrets in my application? So let's say if you're using something like Node.js, you could use the Secret Manager library. And then yeah, you can see over here, I'm going to be using this later on. If you're using other languages like Python or Go, there are other libraries, API libraries that we have written for these different languages as well. Okay. And you can see over here in this function, all you need to do is, based on the client you created using the library, you can just call SS secret version with the identifier to get that secret in your application. And just one thing to note, for this name over here, the name itself, there's actually a format to it. So it doesn't just consist of the identifier that I mentioned earlier on. The identifier is just this secret name part. You actually have to put in the project ID as well as the version. Okay, so for version, you can put in the numerical representation of the version for the secret, or you can use latest if you just want to get the latest secret. Okay, so what are the pros for some of this for using Secret Manager? So compared to our last solution, this is a proper solution that we need. It's a centralized single platform. You can just go to GCP's platform and use the control panel to manage those secrets together with your colleagues. This is one single spot. You don't need to coordinate with them in, let's say, face-to-face to get these secrets written into your use for environment later on. Okay, and you can set proper access control policy so that people can, different people who can read can just read it. People, different users who can write to it can update it. Okay, and as mentioned earlier on, it's an additional benefit for using Secret Manager, which is versioning. So you have this additional dimension which you can use in controlling, like within the application. If you don't want to use the latest version of secrets, let's say if the context of the secret is tied to the application code, you might want to just put hard code the version in to indicate that, okay, I should reference to a certain version instead. And then maybe you have a different application that shares the same secrets, they can use the latest version. Okay, and multiple ways to retrieve, very flexible way to use Secret Manager. And one very important thing is that if you have been using a traditional way of using .env files for getting your environment values and secrets for running an application, you don't actually have to use the same methodology here. Just now you saw I used some application code, some JavaScript code to retrieve it within my application. So essentially you can use something like a cron job to call this code, maybe every 10 minutes to refresh your secret. So essentially what it means is that you can automatically rotate your secrets without having to restart your application. But if you are using the method of using a .env files, you can also create a shell script to use the G-Cloud client, or just write a simple, like let's say for JavaScript, just write a simple script that you can run before you run your application to pull the secrets and write it to a .env file. Okay, but some cons on Secret Manager, I mean, yeah, you need to get more people to onboard the Secret Manager because it is a new tool, and yeah, you have to put it within your process, and you need to set the proper access controls as well. So, I mean, these are required costs or needed things that you have to do in order to use it efficiently. Okay, so just very happy to mention this, that when I used this before, when I tested this before, it was still in beta. So for like companies who need to, or who can only use tools, if they have if they are not in the beta stage, I mean, this is very exciting news that I can share with you, which is that it's now currently in GA. So you can use it together with your serverless applications or even non-serverless applications. You can use this as well. Okay, so I just want to give a very quick demonstration on how we can use Secret Manager. Okay, so over here I have. I'm going to try and make this bigger. Hope you guys can see it. Okay, so you can see over here, this is the, I have this project that's running my Cloud Run application as well as my App Engine app. You can see that I do have some secrets over here, but of course I'm not going to show it. But I mean, let me just demonstrate how you can create a new secret using this interface, the G-Cloud client. Okay, all I need to do is call the command over here, which is G-Cloud secrets, indicate the version that I want to access for a certain secret, and then put in the secret identifier. Okay, and then you can see that after putting this in, okay, yeah, we got our secret value for SGInnovate. Okay. So, and this one is just showing like maintaining one single version. What if I want to maintain, what if I want to access multiple versions? So let's say, you know, I have this secret called test secret with multiple versions. Okay, so on the client, you can try and access these secrets. Okay, so if I go for version 1, you can see that I'll get a single value for this secret. Okay, if I go for number 3, which is the latest version, I'll get the latest version instead. Okay, yeah, number 3. So you see it's a different value. And the latest, because this is the, number 3 is the latest version. So if I change it, the version number to, instead of using a number, I use latest, it will give me the latest secret. So if it's version 4, it will give me version 4. In this case, it's 3. So it just give me number 3 again. Yeah, so okay, let's go back to the slides. Okay, so yeah, that's the sharing on Secrets Manager. Okay, so it's just loaded in. Okay, so yeah, that's all I have for you guys today in terms of discussing regarding secrets and how to embed them, you know, in different methodologies in our serverless environment. If you are interested in the, I did a full write-up on this, so if you're interested, you can just scan this QR code here or just call this bit.ly link. It will give a full write-up on how you can actually use this within your serverless applications. Yeah, so that's all.
Thank you so much for the in-depth and engaging presentation, Weiyuan, and ending off the session. Yeah, so once again, thank you, Hairizuan, Akilesh, and Weiyuan for sharing your knowledge and expertise with our communities. And of course, thank you to our attendees for taking time this morning to tune in and staying all the way through till now. Yeah, unfortunately, we are pressed for time and will be unable to have our Q&A this time around. So if you have any burning questions, do let us know at events@sginnovate.com or reply to a post-event emailer that will be sent to you after this event. So may I ask our speakers to come on screen so I can take a picture? Yes. Yeah. Is Hairizuan still there? Ask this guy. Yeah. Yes. Okay. If you guys could just do a little wave over here, then I will just do 1, 2, 3 cheese and hold on. Yeah. Okay. Wait. Let me just say 1, 2, 3. Okay. 1, 2, 3 cheese. One more. 1, 2, 3 cheese. Thank you so much for your time today. We're very happy to have you on at our events. See you. Bye bye.
Yeah.
Thank you.